Okay, we're going to start off by removing the tire, giving us easier access to the front disc brakes.
This is after properly raising and supporting the vehicle.
Tool. And in this case, we are going to use an impact gun. Always wear the proper safety equipment when using air power tools. With enough leverage to make it easy for you to be able to remove the lug nuts. So something of that nature.
Remove the cap from the brake fluid reservoir. This will allow the air to release as you're filling it back up with fluid that comes back from the caliper as you're compressing the caliper piston. The way disc brakes work, as the piston moves out, the fluid level will drop. So if you have low fluid level, this indicates that you have worn brake pads. There are three types of disc brake systems: fixed, sliding, and floating. Here we see a fixed caliper system with 4 pistons, 2 on each side. Here is a sliding caliper system with the slide and spring being hammered in. Here you see a floating caliper system that uses guide pins and space between top and bottom. Floating and sliding caliper brake systems have only 1 piston. As the piston pushes the brake pad against the rotor, the pressure in the caliper builds up, forcing the caliper to move over, pulling the outboard brake pad into the other side of the rotor. As you can see in this next video, you can watch it move with the arrow. Brake calipers that hang up and don't slide correctly can cause abnormal brake pad wear.
So what we're going to do at this point is we're going to take a C-clamp, a large C-clamp. This one's 8-inch. And I'm going to put it across the caliper, and then I'm going to tighten it. And then which I will show you here momentarily. Here you can see the gap between the caliper and the outboard brake pad. Okay, let's start by removing the C-clamp. Now on the back of this rotor, on this caliper, there are going to be 2 bolts, 2 guide bolts or guide pins that use a hollow hex head adapter with the correct hollow hex head adapter or Allen wrench in the guide pin. You will then loosen and remove the guide pin at the top and at the bottom. They're not going to be very tight. So I remove 1 guide pin. And this guide pin will have a lubricant on it that's silicone based, so it doesn't make the rubber swell and doesn't affect the braking. Come on. And of course, make sure to save that plug. You want to put it back in and so it stays protected. And then remove the bottom guide pin.
Inspect the guide pins for scoring or damage that would cause the caliper to hang up if they were bad and cause irregular brake wear. Otherwise, clean and re-lubricate them.
And again, inspect the guide pin for some wear. As you can see, this has a little bit of wear on it. If they were severely gouged or worn, you then can,
if needed, you can go to your local parts store, purchase a hardware kit that comes with new pins, bushings, boots, and all the hardware for your guide pins.
Up here and down here, we can slide the caliper off of the disc brake rotor. This being the outboard pad, and as you can see, the outboard pad still has a little bit on it, probably about a 1/16 of an inch, maybe almost an 1/8. And then we pull the pad out of the caliper. Oop. Then we pull the pad, out of the caliper, which has the spring device on the back to hold it into place inside the piston. If by chance you have the tools to measure a disc brake rotor to determine if you need to machine your rotor for your new brake pads, you can perform measurements to determine if your brake rotors need to be machined or if you can just throw a set of pads on it. One is a micrometer to measure the rotor's thickness.
Either in the equipment manual or on the rotor itself, there will be published specifications on the minimum thickness. A rotor cannot be machined if it will make the rotor thinner than the minimum thickness. It will cause it to overheat and fail. Inspect the rotor for grooves or heat checks. Heat checks are caused by disc brake rotors being under extreme heat and braking hard, pulling the rotor apart, causing the heat checks. This picture here shows a brake rotor that the brake pads wore down to the metal and have worn the rotor to where it has to be replaced.
And of course eyesight to see if there's any grooves in the rotor, which in this case there are no grooves in the rotor. What I have set up here is a dial indicator that shows us how much wobble the rotor is going to have, what's known as total indicated runout, TIR. So what we can do is this setup here, which has a magnet with some variable arms, allows us to set up a dial indicator that will enable us to rotate the rotor and measure how much wobble or runout we have. Alright, once you have your dial indicator set up and you've adjusted your phase to 0, you can rotate your disc brake rotor and pay attention to how many marks that it moves. You are allowed to have a maximum of 5/1000ths of an inch indicated runout or wobble. In this case, we're looking at probably close to around 2/1000ths of an inch of wobble. So I could get away with throwing disc brake pads on here without turning the rotors, and the brakes will still work. It's usually a good idea to machine the rotors on a lathe, and usually you can have this done for about $12 or $15 at your local tire shop by taking your rotors off and taking them down and having them turn them. In some cases you would probably have to pull the whole hub off, on this disc brake rotor to take it in and have them turned. And of course there are some shops that have special brake lathes that mount to your car and turn the rotors on the car. As you can see here, we have considerable amount of wear on the brake pads. This is an old brake pad compared to the new one. Now something that we want to also pay attention to is how you took the brake pads off, and also look for any identifying marks such as this T for top, or in this case we have an L for left. Now when they mention left or right, it's usually as setting in the driver's seat. So if you're sitting in the driver's seat, the left of the vehicle will be the driver's side. Okay, with your rotor all done, we can go ahead and start putting in our brake pads, making sure again that we find the correct one that's marked. This one has an L on it. Now these clips are going to be awful difficult. They're going to be really tight, and the purpose of that is to try to deaden vibrations. Any type of vibration is a sound, and some of your high-pitched squeals are basically high-frequency vibrations. So disc brake quiet, and these springs that we put on are there to stop or deaden the sounds so you don't get any squealing.
Making sure your hands are clean and no grease on the rotor or brake pads will also prevent brake squeal. Any grease will also cause glazing, which
Then once you have your brake pads
associated
on,
with brake squeal.
then slide your
Machining the rotor makes the rotor true, so the surface of the rotor and brake pad
Or over the
match,
disc brake
giving you
rotor.
a maximum braking efficiency.
back in here. So what we'll do is we'll set our outboard brake pad up against the rotor, our inboard brake pad up on the caliper. We mount our spring, and then we slide the caliper back on, making sure that we get our spring under the caliper mount. And again, this is to help guide, and on top of that, stop vibrations. And then once you have that, then you take your caliper grease. Make sure your caliper pin is greased. Using your hollow hex head adapter, slide it into place and start it by hand, making sure that you get it to go in as far as quite a ways. This informs you or identifies that you haven't crossed the threads. So you want to go in as far as you can with your fingers, because there's nothing like accidentally cross-threading this and tearing up the threads in your caliper mount. You don't want to do that. Then once you're sure that it's in, you can go ahead and tighten them down. If you're following your manual, you'll probably want to tighten them down to about 20 to 25 foot-pounds of torque, which is tight, just tight. And at this point, your trusty brake job would be done on this one side.
After installing your new brake pads, go in and step on the brake pedal a couple of times. The brake pedal will first go to the floor until your calipers and pistons get set. Then the second time you brake, everything should be set properly. Nothing like doing a brake job, putting the wheels on and backing the car out, and the first time you step on the brakes, the brake pedal goes clear to the floor and you hit someone. Always step on the brake pedal after you've installed your brake pads.
Once you have your caliper all back together, you want to make sure to put your plugs back into the caliper guide pin bushings so they stay clean and lubricated. If you leave those out, you may get dirt inside these caliper guide bushings and boots, and the caliper will begin to hang up and will use mostly the inboard pad to brake. So the next time you do a brake job, if the caliper has gotten hung up, your inboard brake pad will be very thin and your outboard brake pad will be thick. That's a clear indication that the caliper was hanging up and wasn't sliding the way it should, or in this case floating. This is a torque wrench. It's usually a good idea if you torque the wheels down to ensure accurate tightness of the lug nuts. You do not lubricate the lug nuts, nor do you lubricate the studs. And this torque wrench will identify when you've reached the proper torque by making a click sound, henceforth known the clicker. In this case, we're going to move the locking flap, and then we are going to set on this gauge how many foot-pounds of torque we want on the lug nuts. In this case, when I go up, I'm going to spin this knob until I get to about 85 foot-pounds of torque. That's where we want it. And then I want to lock the flap. Now we will tighten each one of the lug nuts until it clicks on the torque wrench, which is set at 85 foot-pounds. So as I put it on here and I tighten, you'll hear a click. That means that it is tightened to 85 foot-pounds. Now I'm going to go across from it in a star pattern, kind of in a star. As soon as you hear the click, it's at 85 foot-pounds. Then I come over to this one, it's at 85 foot-pounds, and this one, and this one. And the reason that we're doing that is to make sure that the lug nuts pressure is almost even on all 5 lug nuts or studs. When the rotor gets warm, as you do a lot of braking, if those are not tightened equally, when the rotor gets hot, you'll find that it will warp, giving you a high total indicated runout as we measured earlier. And this will result in a brake pedal pulsation when you stop, or the car pulsating when you stop.
I want to thank you for watching and hope this was informative, and I look forward to your constructive comments.